Hello everybody, welcome to day 15 of Advent of Code. I'm kind of skipping for now day 14 because I don't have that much time today, but I wanted to at least tackle one problem, so I picked day 15 because it seemed it could be quite simpler than day 14 and it might be easier to implement. So let's go and try day 15. So today we're dealing with lens library. And there is a lot of backstory for it, but the thing is that we'll be implementing some kind of hash algorithm, which will take a string of characters into a single number in the range of 0 to 255. We start with a value of 0, and then for each character in the string, we determine the ASCII code, which is kind of the value of the character. Then we increase the current value by the ASCII code that we just determined. We set current value to the value multiplied by 17, and then we do a remainder by 256. So so far so good. So this is just showing how to apply this to the text of hash itself. So it kind of calculates that final value. And we have an initialization sequence, which is a comma-separated list of steps to start a lava production facility. We ignore the new line characters when parsing the sequence, and our goal is to verify that our hash algorithm is working. So to verify that our algorithm is working, we get a sum of the result of running the hash algorithm for each step of the initialization sequence. So for example, here we have 11 individual steps, and the result of running on each of them is as follows. So we kind of calculate the values and we sum those results to get the final expected puzzle solution. So let's try doing this on the sample input. So I will take this and then I will take input, read all lines, and for each line of the input, actually let's just see, this initialization sequence is just one long line, so it should be just one line. So read lines 0, we could take this, and then we can read all text. So that should be fine. So one single string, and now we can split that string by commas, and we can then also make sure that it's without white spaces, and we can trim the entries. Okay, so we get the whole input parts, and then we will have some kind of hash algorithm, so hash, which will calculate for a text or input, we'll calculate that hash thing. So we start with value of 0, then we add up, and for each character, in input, we add plus equal C. So we add that value of the character, then we multiply by 17, and then we do value modulo, and that's gonna be 256, right? So 256 multiply by 17, and yeah, that should be fine. So let's see if we do this and then return the final value, we should get the hash, and now we can run this for all the parts. So running total is 0, and then we do for each parts we do running total plus equals the hash. part. So now, if I didn't miss anything in the description, we should get the proper result here. 1320. So let's see if this works on the big input as well. So let's run this. 52,000. And that is correct. So we have solved the first part of this problem. So let's switch to part 2. So to convince the reindeer to bring us the page confirms that our algorithm is working, and we have 256 boxes numbered 0 through 255. These are arranged in a line starting from the point where light enters the facility. So they have, the boxes have holes that allow light to pass from one box to the next all the way down the line. So inside each box there are several lens slots that will keep the lens correctly positioned. Alright, so we can insert or remove lenses as necessary. Along the wall we have a large library containing lenses organized by focal length, ranging from 1 through 9. Book goes on to explain sequence process call. Okay, hash map is the procedure. Sequence of letters indicates the label of the lens on which the step operates. So the result of running the hash indicates. Okay, so we just take now the sequence of letters first. So that would be like this thing. And there is then equal sign or a dash. If it's a dash, then we go to a relevant box and remove the lens with the given label if it is present in that box. If the operation is an equal sign, we will add focal length of the lens that needs to go into that relevant box. If there is already a lens with the same label, replace the old lens with the new lens. So let's see, SCM. Okay, so each of the sequence of label of the lens on which the step operates. Okay, so essentially the letters themselves are the label. And then we have okay, adding OT, AB, PC minus, so it removes the lens with the label that's there. Let's see, so it adds here now OT7, and if there is a one with the same value, then we replace it. So CM2, some kind of replacement here, sample for replacement. I would like to see PC minus, PC6, OT. Okay, so this is the replacement. So OT9 is replaced by OT7. Okay. All right, so I get this, I think. So now what do we do with? Okay, within each box, lenses are listed from front to back. Each lens is shown with its label and focal length in square brackets. So the result, there will be some kind of calculation over all those boxes. Okay, so we kind of calculate all of that to get the total focusing power. All right, so let's try first on the basic example. Again, I will take the whole existing program that will also reuse partially, but now instead of getting the running total, we will do a little more operating on it. So technically we need to split. So yeah, we need to check if the part contains an equal sign or minus, and then operate on it somehow. So let's see. So we'll have a list of boxes. It's gonna be an array of linked lists, and I will have some kind of can we call it, lens. Yeah, so it's gonna be a lens. So let's create a record lens. It's gonna be string label and focal length. So that's gonna be our lens. And this is gonna be a linked list of lens. Or rather, let's do, it's gonna be an array of linked lists of lens. So we'll have a linked list in each of the boxes, and that's gonna be of 256 size. We'll need to initialize it, so boxes length. I will make sure that each is initialized, so boxes I equals new. And now we have linked list everywhere, so we can easily push into new lenses and remove lenses, and it will also automatically shift the additional ones next to each other. So what I will do is I will check if part contains minus, that it will be removal, and else addition, insertion. So now for insertion I will do so I will take parts 2, yeah, maybe like this. We'll split it by the equal sign, and now label will be the parts 0 and focal length will be parts 2. So now what I will do is I will hash box ID will be hash of label, and then I will go to, so either if also I'll take the box And if the box contains the label already, so if it contains the, okay, I need values. How is it done here? I need to find the, okay, so maybe I need to do it like this. Right. Okay, so let me do this like a little bit differently. So node lens linked list with label. So searching for a lens with a given label in the linked list. So yeah, you need to enumerate the box to find the label, and if it's there or not. So this will, we should find the lens. So if find lens label is not null, if there is already one with the same label, then we'll replace it. So I can do actually is to turn this into a class, which is going to be more useful in this case. And I will do prop string label, and I will do focal length. So I will be able to overwrite the focal length easily. So string label and focal length. Length, so I will easily now be able to set a new focal length. In this case, it shouldn't be a problem. So I will do override. So if it's not null, if it's a lens value dot focal length equals focal length. So I update it by the focal length, and if it's not there, then I add that to the beginning. So a box at first focal length. And if it's not, if I'm not mistaken, it should be added to the beginning, right? So let's see. If there's already a lens with the same label, replace it. If it's not there, add it to the behind all the lenses already in the box. So add last. Okay. Now removal. For removal, we will take a label which will be part, well, ends with my dash. So we remove that dash, and then we hash that, and then we get, well, box ID, so it's consistent. So now we get a box, and if we find the lens, we remove it. So we find the lens with the label, then we remove it. And that should be it, I think. Yeah. So I think that should be it. Now we just need to calculate the final result. So running total, and now for each box in boxes, we'll be calculating, or maybe like we need 4 instead. No, I need 4. So 4 boxes length. So I will have the 1 plus the box number of the lens in question. So it's going to be box number. Then slot number will be 1 for the first lens, 2 for the so on, focal length. Okay. right? So for each lens in boxes, I will take lens in number. It's gonna be starting at 1, lens number plus plus, and I will be calculating number of the box times the slot times the focal length. So box number, lens number times focal length, and adding that up until we get the final result, which should be here, running total. And I'll just to make it safe, I might need to make it larger, but we'll see. So let's run this on the simple sample. 145, and that's correct. So let's try the big one. 248,000. So let's see. And that is correct. Okay. So that one was not that tricky. It was actually just reading the description properly and applying everything the right way. So yeah, this one was not that complicated, I think. So yeah, I'm pretty happy that this worked out, and it was kind of easy and short one. So I hope you enjoyed it, and I will be back with another video about how ChatGPT can handle this problem, and I think it could be reasonably easy for ChatGPT as well. So we'll see, and so stay tuned for that video, and I will be back with more Advent of Code videos later, because there is still a lot to do, and I'm quite a way behind, so I have to catch up. So thank you very much for joining. If you want to get notified about new videos, please subscribe or give this video a thumbs up, and I will see you in the next one. Bye bye.